are like wires. We have different layers. This is our schematic. This is USB Type-C. This is the fuse. It stops large currents, and this is a DTA style. It stops large spikes of voltages. These are pull-down resistors, telling the USB Type-C that it is a device. It is a powering device, not. It's a sink device, not a source device. So you should be careful about that. These are decoupling capacitors. They were for filtering, for DC, and they were both for powering the IC when there is voltage drops. This is the blinker stage. This is the LED. Yeah, PCB layout. Let's start with that. I come to here. I click on PCB editor. As you remember, we did yesterday. Click on F8 or this button to import all the components. We did the gereksiz şeyleri kapatalım. Let's play some games. We came to tools, assign footprints, and we assign the footprints through here. You remember what footprints are? Pads are non-coated copper layers, and the shape of the IC, the shape of the components, the shape of the thing, all of it is called the footprint. And which are these? These are the footprints. Okay. I forgot to do something yesterday. I come to here. This is important. You do electrical rule check. You check the schematic if it's correct. I run ERC. I have 2 errors. Generally, I get errors on power pins. So as long as it's not a power line issue, you should check it. Probably something is not connected, or probably you didn't choose a footprint right. So you should always do checks. For this one, we do electrical rule check. After we are done with the PCB, we do design rule check. So if it is correct or not. Yeah, you are making a PCB. Don't put 2 components really close. They cannot make it. They print it. We used to make PCBs like this. We would print it. We slap it on a FR4, and then we would use light to etch copper on it. So if you had really close traces, they would come together with the acid. So we have physical capabilities, and those capabilities are stated on the sides. So let's check one of the sides. You can use any of them, GLC, PCB, PCB-way. I like EKA PCB in Turkey. So you go into their site, okay, and then they tell you what they can make. So you are engineers. You are supposed to make things that are manufacturable, that can be made possible. So if as a designer, you should think of the manufacturer every time that you are designing. If it cannot be manufactured, you are not doing anything. You're just playing with the KiCAD. Like, you're not supposed to do that. These tell you minimum drill sizes. We are going to make vias. We are going to make holes. Minimum copper thickness. So we are going to use these. Yes. Şimdi şurada vardı. Ama nerede? Evet. Blocks. Yes. Yes, we are going to use these. These I copied from GLC PCB, which is a Chinese PCB company. You can order them. They generally come like in a couple of days. I generally suggest them if you are going to order in bulk, but you can decide the prices. You guys are the engineers, so I'm not willing to make every choice for you. Let's talk about. Yes, let's talk about copper pores. So, 1 ounce per feet is a measurement. So it means 35 microns. the literal thickness of that copper layer that you see, you choose, after you're done with designing the PCB, you send the files, those are called Gerber files. You send the Gerber files to the manufacturer. When you're sending them, you choose like through the options. How thick do I want my copper traces to be? How large will my PCB be? Through those options. You can choose 35 microns, 70 microns, and we are going to use them to choose traces, but I'll let you guys copy from here the minimum clearance, the minimum track width. Let's do it together. I come to this, I click on this, I come to constraints. These are for us and for the manufacturers together. So these will allow, they will show, like, let's read through them. Minimum clearance, the distance between the traces. This means distance between the traces, distance between the components. This is annular width. This decides like the distance between the hole and the pad. So minimum like hole to hole distance, copper to hole clearance. These are all things that we're going to do. So I come here, all of them is 0.2. These 0.2, 0.2, 1 dash 0.6. I click tab to go through them quickly. You can do the same. I click tab 0.15, tab 0.15. Yeah. Minimum through hole 3, 0.2, 0.1. And for the other one, 0.075, 1, and 0.2. So you should always, when you start a new PCB, after you're done with the schematic, you first do the constraints so that you can like have a base of foundation to build the PCB through. And after we are done with them, I just click OK to save, and then open the same window through here. I come to predefined sizes. Now, we are going to decide on our vias sizes and our trace sizes. Those are really important. You don't want to burn your PCB trace when you put like 3 amperes, 10 amperes of current through it. So we have a special design guidelines for that. Yes. I think this was called. IPC 221A. This document is your holy grail, okay? If you want to be a good PCB designer, you should read this at least once. It tells you resistances, how to calculate them, which type of traces are good for which dielectric constants are there. Will your PCB conduct electricity if the current that is going through is like high power? Which high currents, which gigahertz can you make through this? So this is a good document. I suggest you read it. From here, I'm just going to use this one. How to choose cross-section of a trace from the current that I'm going to run through it. Okay? So I wrote a special MATLAB comment for it, and I'm going to show you how it's calculated. So I decide beforehand, look at the components data sheets, and find how much current that are going to be pulled by the components themselves, and I want generally my power lines to be able to take that current. Okay? So if you're going to draw 5 amps of current, you come to here. I come here, and I assume generally it's 20 Celsius. I come 5 currents, and I come down. I need 100 mil square. So I know that now, and I will use that information to decide the thickness. Decide on the thickness. So the thickness is there are 3 dimensions: length, the thickness, and the height. The height is decided by the copper fill, the copper pour that I talked about. Here, you choose the ounce of copper per feet. So you can decide 35 microns or 70 microns. Okay? And I know the copper fill this. I know the copper fill. I have a constant, which is this constant, to turn mils to millimeters. So we are working in millimeters, that's why. And I put the value that I decided here to here to decide on the thickness of the PCB trace. Let's do it together. This was the formula, and I have the MATLAB code for it. Keşke gözükse. Niye gözükmüyor? Neyse, we calculate it through here. Generally, I can give you guidelines. If you are going to run like small PCBs, not power PCBs, those are special, you need to use this. But if you're just like making a signal PCB, radars, I don't know, antennas, Bluetooth, any of that, just you can use 0.5 millimeters for the power, and for the signals, you can use 0.25, 0.3, 0.2. Those are fine. So let's do it together. So here, I'm going to add 0.5, and I'm going to add 0.2. MATLAB açılırsa öbürüne gösterelim. And let's add the vias. 0.8, 0.8, and 0.4. Okay. These are now my tracks, traces, and vias. I'm going to use them.
How did you bring this PCB to the PCB section? When I open it, it's just empty.
I click on F8 or this button, update PCB, and they come here, like around here. I take them and put them to here, which is in the middle of this section. More questions? You can just stop me if you want.
Do you share this file?
Hangisi? IC221?
Yeah.
I can. There's online versions. You can find yourself as well. I can share it if you want. Yeah. So, if you guys are good, we can continue. Yes. Generally, I look at the components and eyeball the PCB size. But if you don't want to do that, if you guys have a specific size, you do that through like measurements. I'll show you. If I click on Control Shift M, I can measure things. Yeah. But more important than that, I would like to introduce you guys to layers. So yeah, I have solder mask layer. I don't use it, but I should talk about screen first. Okay. We have multiple layers in KiCAD. Some of them are manufactured, like really made in real life. Some of them are for the manufacturers, and some of them are for us. So they don't even see it. So there are multiple of them. The topmost layer is always the silk screen. Silk screen means like the writing on the PCBs that you see. It says, I'll close it so you can see. When I close it, you see. It shows U1, C1, R1 that you see and solder them. Like it is used for labeling the components. Yeah, you got it. And I have the copper layers, the front and the back. We can have intermediate copper layers, but we're not going to use them for this project, so we just have two. On top of them we have the silk screen, so it goes silk screen, solder mask, copper, FR4, and we have back copper layer, solder mask, silk screen. So when they make it, they make it this 7 layer PCB. Yeah. So we can change everything through touching those. So I come to front, silk screen, and the fabrication layers. We have front fabrication, back fabrication. these are what the other manufacturers see, so that they can make the PCB. It shows the length, the type, what component it is. We can turn it off for now. Okay, we can turn it off like this. I generally start placing components by clicking on them. I click on it. I generally like making things that are going from left to right, and the power coming from up to down, if I can. So if I'm having a signal, it comes from left to the right. So this is the USB receptacle that we are seeing. I can show you this. Before we make the edge, I can click on this 3D viewer, and this is the receptacle. These are resistors, these are capacitors. This is the DTVS diode, and then F1. This is the polyfuse, and this is the IC that we're going to place. So as you can see, it already looks like a PCB. We're just going to define the edges, change the orientation, decide on the measurements, and wire them, and then we're done.
Where did you open the 3D book?
I click on this button.
Oh, okay.
Or you can do Alt 3. I think that works as well. Yeah. I know. Now, when you start to design a PCB, you take the most important parts and then you place them first, and then decide on the other ones after that. Okay. I generally like placing the big ones, defining the edge of the PCB, and then placing the little ones inside like the PCB that I decided on. So I place this. I come here like that. Okay, and I put it around here. So it will be a PCB around like this. Yes. So to define the PCB, I come to edge cuts layer. Görürsem edge cuts layer. So I make sure I click on N, and let's not do it then. Çok büyük. I click on this, okay, and I make sure that I choose one of the big ones, okay. And since we are going to order from China or Turkey, it generally makes sense to order them from millimeters. But if you are like working with US, you can, or like you have specific components that are really suited for this, like mills, for the mills, inches, you can do in inches as well. But I generally do in millimeters. I come to here. I make sure that my grid is large first, and I click on the edge cuts. I make sure that I'm on edge cuts. I come to here to add a line. I start from here. You can decide on the length, like this is a 40 and this is 25. If you can make your PCB small, like 25 by 25, it makes it cheap. So if you can make it like that small, that's good. But once you go over that size, you can increase it to 100 by 100. So they generally price it like that. But I would suggest you, my information might not be up to date. I haven't ordered PCBs from China for a long time, so they might change their policy. So look yourselves. Yeah, I define the edge cuts through this. Now I have my PCB in, like I just made the edge of my PCB. Congrats. Do you guys have any questions for now? I'm going to move on to the next stage.
We get so much errors because we didn't close some of the ports. Would it be a problem?
Which ERC mi DRC mi?
Bak şu gösteriki çoğu port kapatmadığımız için schematic kısmında bayağı bir fark.
You're supposed to do it. You okay, I'll show you again. You come on top of them.
We don't.
You don't. Yani, if there are a lot of errors and you miss one, it's important. I come to here. I click on Q, and it just puts a non-connect symbol on it. Okay. Click Q, or you can click on this symbol. That also does that. Sure. Yes. make sure that you do not connect. And after you're done with that, to import the changes to your PCB, you're supposed to come to the PCB editor and then import the changes through update PCB through schematic, which is at F8 or this button. Yes, after you make any change on the schematic, you're supposed to click on this so that your changes go through. Okay.
What was the LED's footprint name?
Yes. Huh?
What was the name of the LED's?
The footprint.
footprint?
Yeah, I'll show it again. Tools, assign footprints. LED THT, LED D3 millimeters. Yes. THT. Şey var. Make sure that you're on LEDs. Come to LEDs on the right side. Make sure that you're on THT through hole. TH means through hole. And then you come to THT, that's 3 millimeters. This is it. Yeah. You make sure you click on that. Yeah. Did the other guy send you the files, the zip files, and the
I'm not sure.
footprint files? No?
Maybe.
Göndermedin mi? Hiç hoş olmamış. Okay. Geçen günler I sent them. Okay. If any is missing, I'll just show them to you. This is, I think, easier to see than the B building. Is any of the footprints missing? Did you guys, is any of you guys left behind? I can just explain the part again if you guys are back. Okay. Çok iyi. Then we're done with the schematic as well. Yeah, cool. Yüksek ihtimalle geri gideceğiz de ben bir şeyler unutmuşumdur diye. Mesela label'ları unutuyorum. These labels, I was talking about labels and how important they were. As you can see, the footprints show the labels names. So when you are connecting them, unless you label them yourself, KiCAD will going to label them for you, and they will be really long, and you're not going to read them, and it's just a mess. This is much easier. So I come to this grid selector, and I make sure that I'm in smaller size now because I am done with the edge cuts. And we are going to start placing components. So, before that, we are going to define cover zones. Yeah. Yes. Şimdi. So I come to cover zone, front cover zone. I click on this. Which layer I'm operating on is really important. And you guys see what layers are now. I told you it was like, it's not easy to understand before seeing it. Now you see it, there are layers, and I make sure I'm operating on the right one. So I come to front cover. I click on this button. Okay? It is fill zones. As you remember, zones are coppers that are separated. Yeah, yeah. And it's like traces, but they don't have an edge. They allow you to fill the zone. It's like a plane. Plane gibi. Aynen. Böyle yaptığım zaman mesela burası full front cover'ın bu kısmı benim seçtiğim şeyle ground'la kaplanmış olacak. Okay? I click on it. I click on here. Okay? So I come to ground. I select ground for the front cover layer. I come to here and I make sure that I fill all of the PCB with ground. Okay? I'm done with the front layer. I go to the back cover layer. I click on this again. Bam. I'm adding ground again. You don't have to do this if you are making a power PCB. But this really helps if you are going like if millivolts. If you have a millivolt signal on somewhere on your PCB, adding ground layers, adding copper fills of ground to top and bottom of the PCB, it really helps. Okay? Zaten yaptıkça daha da neden yaptığımı anlarsınız. Yes. Now I'm done with the copper zones. I press on B to fill the zones. As you can see, they are now filled. The copper at the front and the back. I don't want to see them, so I click on this all the time. Yeah. Now it was warning me before to click the to connect the grounds, but I don't need to connect the grounds now because, as you can see, grounds automatically connect now because I added the zones. I don't need to think about ground anymore. Like on real schematics, I don't think about grounds. But as I move every component, I click on B to fill the zones each time to change the zoning. So let's do it. Like think of this. I move it. C, the zone stays here, and it is all connected to the ground. So to change it, I click on B. This now component comes to here. Make sure that you, as you change the place of a component, make sure that you press B multiple. Always press B. Trust me. You change something, you'll forget it. Always keep on pressing B. Fill the zones. Yes. I start with. It is confusing when you look at the PCB. It's like, where do I start? What do I do now? It helps you if you have the PCB like this, and you have your schematic like this. This also helps for adding the footprints and things. Let's make sure that we don't see the zones. I click on this to make the zones invisible. I don't want them to touch my thing. Yeah. See, I can click on them, interact with them. I make them invisible, but they're still there. With this, it is just a view thing. I start with the most important components, as I said, and I come to here, and I come, for example, I'm not going to connect the grounds, but I want to connect the polyfuse and the TVS first. Without power, you're not going to do anything else, so it's always good to connect the power first, do the decoupling capacitors, do the fuses, do the diodes that you're going to need. And after you are done with powering and wiring, you can think of the other things, but we are not going to wire first. We are going to change the places of the components so that they are easy to wire. If wiring is hard, if you do not place the components properly. I want as little space between each of the connections. So I can see these are labeled polyfuses. So we are supposed to connect polyfuses to these. Yeah. So the polyfuse connection is here. I rotate it, bring it to here. After that, I'll get. I can change it as I want. After that, I'm going to press B to make sure that I can add the thing. So I will need the polyfuse and the DTVS. Yes. Like this. It is always good to make sure. Like when I'm placing the components, as you can see, I am trying to minimize the distance, but without like overcomplicating. But I can put it here, like for example the fuse. I make sure I am away from the USB receptacle, but I can put it here. It is like hard for some of the manufacturers to make this, so I try to make their lives easy. If I do not have to make things as close to each other, I just don't make them. But if I have to, because we set the parameters here correctly, constrained correctly, we can do it. But I told you, always think about the manufacturers. I click on the labels of the things. This is on the silk screen, by the way. This is the silk screen. When I click on the things, this is the silk screen that I was talking about. It just has writings on it and labels the components for you. You generally don't subtract, yani bir şeyler çıkarmayın silk screen'den, you can add to it. You can add labelings, you can add other things, but you don't delete things from the silk screen, they're important. D1, I drag it, I press R to rotate it, as I did for these as well. I press R to rotate them, or I can. Yesterday someone asked how to rotate a component. I'll do it here. I'll copy this, and if you press X, that is going to rotate the component. It rotates. The X button. Yeah. It sometimes is helpful. You make sure that your schematic is clean. Do you guys have any questions? I'm going fast. Okay. After I'm done with the polyfuse and the ground, how did I wire the polyfuse? Kendi başıma yaptım, nasıl yapmışım? Polyfuse böyle koymuş. Okay. Let's move things around a little bit. So we don't need to connect multiple polyfuse connections. So I just don't need this. Probably here is fine. But I'll need a lot of 5-volt connections. So I take this. And I am going to take the decoupling capacitors as well. These are for the powering. And I told you these are for filtration and powering the PCB. So you put them in your power ports and close to the power pins of the ICs when you have a decoupling capacitor. Unless they're not going to do their job properly. They're not going to filter things, they're not going to power the PCB properly. Make sure that your decoupling capacitors are close to the IC's power pins, okay? Always, always. That is their job. Yeah. So I click on the decoupling capacitor. When I click on the schematic, I automatically go to the PCB layout. So that's why I keep them in a separate window. If you have like two screens, you can put one there, put the other there. It's really helpful. Sometimes I do it. I take the other one, the decoupling capacitor. I try to put it close. This one's the bigger capacitor. Yes. And I put the other one next to the DTVS. Yeah. And I'll make sure that they are facing right way up. Any questions?
Her zaman neyle kullanmaları?
The decoupling capacitors that I have.
I see, I guess you said.
Power pins. Here, for example, you power the NE555 through 8 VCC pin and ground pin. You want your ground, you want your decoupling capacitors close to VCC.
Okay, VCC, okay.
Of the power pins of the ICs,
Okay.
or the V-bus in this case. Yeah, you
all
want
of the input,
all of the power pins. You want decoupling capacitors and power pins that will help you with the SNR. It will help you with the noise a lot.
Okay.
When you are designing things. Sonrasında bunu da böyle yapayım. Daha kolay olsun. Bunun değil mi? Oh, I made the mistake in front of you. I was like trying to decide on the PCB layout without looking at the schematic. You're not supposed to do that. You always click on the schematic and then do the changes through there. There you go. Yes. And I am done with the USB receptacle for the power ones. Now I'm going to add the pull down resistors. So as you can see, the spider web comes to here. So we are putting it to here. I'm going to snake around through here and connect this there. Or I can add a via. We are going to talk about vias as we are going to place them. And this is the other pull down resistor. I can place it close to here. Yeah. And here we go. Yeah. I always, from my habit, I press B, as you can see. Like when I press B, you get this building zones, filling zones notification out of habit. So it's a good habit to have. Always press B. Sonrasında. Let's go. We are done with the receptacle components. Let's go with the NE555. So let's see. Which capacitor is this? As you can see, we need to connect to here. So I change it to there. I take the R4. It is connecting to where? It's connecting to this and C3. Let's see where this is. is like a puzzle. You're trying to solve a puzzle like me. If we do it like this, I think we'll be able to do this. I try to make sure that the lines that I have don't have a Y component. So they're not slanted. I try to make them as straight as possible. See, this is not straight. Look at the blue line that is connected to this. I try to make this.
Now what is the problem?
It will make it really, really easy when you're connecting things.
So it's about soldering?
Yeah, this is about connection like this, via traces. When we are going to trace them, it will be like this. Like this is a trace, for example. But if it was here, look at it. Ah.
Oh,
Yes, I don't want unnecessary traces. They're always bad. If I don't need long traces, I don't want them. Sometimes we use traces to make antennas, and then we do magic. We take a trace, we do this. This is an antenna now. I don't want antennas on my PCB sitting around. If they are not supposed to be there, they are not there. Okay. O yüzden şey yapıyorum yani. And the R3 is here, R4 is here, C3 is here, C4 is here, 5 volts. This is the decoupling capacitor, so I make sure, so that I make sure that it's close to the IC as much as possible. I have a lot of space, so this is a big PCB. I could have made this much smaller, but I want you to guys to be comfortable placing it as well. I could have shrink this to this size, like I could have made this 20 to like around this size, 35. Yeah, this would have been a good fit. But it is easy now. I also press Ctrl S to save it. If it goes away, your PCB is done. So always save your files. Onun dışında devam edelim. I keep on clicking things and connecting them. So I think we're done with the parts here. As you can see, this is that, this is this, this is that, and this is that. Yes. I am done with connecting them. C3 şöyle yapsak. Bak. And it is easier to connect these two like this. Ya da bu böyle olsun, bunu böyle getiriyoruz. Yes. It is like a puzzle that is always comes up different. I'll show you the one that I made on my own before this workshop. It looks completely different than this one. And I'll try to make the distances as short as possible. It comes to this. I don't want the LED too close to the edge. This can be happening like this is a 3D. This is the LED. I don't want the pads to be close to the edge of the PCB. They might cause problems, but the 3D footprint can move around the top large portion of it. So I can take this like this close, but I don't want like none of this. Yeah, I make sure that they're away from each other. So placing it here is fine like this. So this is okay. I made a mistake again. This is not the power pin. Always check the power pin. This is the VCC. This is the power pin. İşte uyarmıyor musun? You guys know what I'm doing, right? I am clicking on the labels on the set screen, and I'm just moving them around with R and my mouse. Sonrasında we added the LEDs. I think we are ready for everything. Baksana ne kadar aydınlanmışlar. Gelin abi. Ne yapıyorsunuz?
Hocam C4'ü oraya taşımanız ne işe yarıyor? Kaçıyor.
Which one?
Capacitor 4. Why we took it to the power pin? Closed it because of
Look at the connections. There is the reset pin, and this is the VCC pin. 4 4 and R both connected to the 5. I saw 5 volts and I thought, oh, this is the bulb, let's put the capacitor here. But it is not. This is the VCC. 18. Yeah, that was the mistake that I made. C3 comes here. Yes. 5 volts comes to here. 3 comes there. Yes. I can even make this closer. Now I see that I'll show you this. Yes. As I'm trying to select this, I have a problem. I just keep selecting the zones as well. It is really annoying. I come to here, I turn off zones, bam, and I come back. This was an object. I come back to layers. I also turn off the edge cuts. Bam, nothing is here now. I can select them freely and then open the edge cuts and the zones again. Bam. This was easier like that. 5 voltları yani istiyorum ben. Nasıl olacak? Şurada böyle gelsin. Şöyle gel abi. Sonra böyle gel. Yes, as you can see, I'm trying to minimize the distance. I might populate the PCB like this, but long traces also means like long resistances. I'll show the resistance formula as well. Yes. You know, you saw this in physics 102, maybe one of you guys didn't take it. This is still the first semester. I'll explain this to you. This is the resistivity constant for the copper. It is affected by length, thickness, and fill. If I increase thickness, I decrease the resistance. If I increase the height, which is the copper fill of it, I decrease the resistance. If I increase length, I increase the resistance. Generally, it's not a problem, but for antennas, for sensitive wires, if anything is in millivolts, you definitely don't want high resistance. No high resistance. So keep your try to make sure that your wires traces are short if your signal is really small, like in millivolt range. So I'm doing this out of habit, like trying to minimize the distance. I don't need to. Like I calculated the trace length. I didn't calculate it. Ama yapacak bir şey yok. Yani normalde yapmam lazım ama ona başladım. I calculated using this formula. Anlamadınız yüksek ihtimalle onu aktif olarak yapmadığım için. Lütfen açılsın. Let's go. Okay. I do it again so you guys definitely understand this now. Okay. Let's say I want 5 amps of current. Okay. I want 5 amps. I come to 20 Celsius. It is 100 mils. So I just got that number. 100 mils. This is, as I told you, IPC2201A. You can find it through here. I add mils 100. And this is the constant that I was talking about. And I set the field. If I choose one, generally there are 3 that I see. Maybe there is 3 ohms per feet, 5 ohms. I have never seen that. Never in the like stajlarda falan da görmedim. Öyle bir şey belki vardır. This is 1 ounce per feet. It is 35 microns. 2 ounce is 70. If there is 0.5 ounce, 35'i yarıyor böyle. Böyle.
Kalınlık mı oluyor bu?
Aynen kalın height gibi düşünüyorum.
Ne işe yarıyor?
Ben şey yapıyorum ya. Copper zonlarım var ya. Copper zonların kalınlığını belirliyor bu.
Yani işe özel bir esprisi var mı kalın olması, ince olması?
Var.
Ne işe yarıyor? Kalitesini belirler ya da şey mi?
Sen içinden belirli bir miktar akım geçireceksin. Eğer çok ince bir şeyden, trace'den bir miktar akım geçirirsen, 5 amper falan, 10 amper geçirirsen sen o trace yakarsın. Aynen.
O zaman hep kalın.
Ha?
O zaman hep kalın.
O zaman da şey oluyor, yer kaplıyor, çok fazla bağlaması zor oluyor, viyalar ekliyorsun, bir sürü şey alıyorsun, o hoş değil.
Yani optimumu seçmek.
Aynen. We are engineers, we are supposed to choose the one. That's why I'm teaching it. questions? Okay. And then I just calculated to you here. I have a PCB thickness of 18 millimeters. Yes, like that. Yani buradan gelsem şunu seçeceğim. 1, 2, 3. 1, 2, 3, 1. Yeah, 1 millimeter, 1.8 millimeters. If I want to pass 5 seçmiştim. 5 amps of current. So I generally no one passes. Yeah, if you're not powering like an electric car or like a fridge or like a power thing, unless you're doing power, you don't need this thick traces. But it's always good to know how to do it if the needs comes. O yüzden ya 0.5 seçtim mesela. 0.5 ne kadar yapıyorum şöyle bakalım. Üründe şunlar var. Ne yaptığın zaman da 0.5 yapınca mesela 35 yapınca ne oluyormuş? Yani 27'ye denk geliyor. 27'ye denk geliyorsa 27 2 amper geçiyor mesela. Formülde siz de biliyorsunuz, siz daha hesaplarsınız zaten.
Bizim devreden kaç amper geçiyor? 2 amper geçiyor.
Bu devreden mi? Hiçbir şey yani. 100 miliamper belki. 100 miliamper. Zaten that's why I picked the polyfuse 500 miliamperes. Evet, yani ondan çok fazla bir şey değil. O kadar küçük bir tane LED var. LED yakıyoruz. Bir de IC var. IC powerlıyoruz. Allah. Nasıl ne kadar zor oluyor yani. This is really basic. But if you are going to make your own, like big PCB, you look at the data sheets. They tell you maximum current that the IC each component takes. You assume that all of them are going to take throughout the current at the same time, and then you make your calculations on that. Yes. I think we can start with wiring. No? Yes. I click on zones, filling zones. I again start first, as I told you, with the power. I come to polyfuse. These are the most important ones. As I told you, Type C has both sides, so I'm going to connect 2 for each pin. So each connection has 2. That's why we're going to connect these sides together with this one, polyfuse. I click on I click on the PCB view, I click on X, and I choose my track as 5 because this is a power, this is one of the power ones. I click on power, I come to here, I connect this one, hold on, I click this one, I'm doing it wrong. I choose front and back couples. I was doing it because it was blue, I was doing it back. I was doing it in the back, but if I want to connect it, I need to use the top layer. I wasn't connecting anything basically. SMDs are sitting on the top, and I was connecting through underneath them. It wasn't. There is no copper connection there. There is no pads. I'll show you. Option 3. Nothing. SMD device. The TH components. This is the LED. This is the IC. This is the receptacle. Except these, there is nothing. But the pads are here. So it's important to choose which side you're doing it. And 3D view really helps on this. I click on copper, and then I click on X to wire it, and do these, and do these. As you can see, when I connect things, the web trail, the web network that I was talking about goes away. So I connected them like this. I click on B. I don't need to click on ground. O bir şekilde bağlanmıyor. Ona yapacak bir şey yok. Birazdan pull down'u nasıl bağlayacağız? B. Aşağıdan bağlasak nasıl olur? Şöyle gelsek. B bağlanacak, bu B bağlanacak. Okay. I have this issue that in the front layer, I wired it so that the polyfuse blocks the way of this pull down resistor. What do I do now? How do I connect it? Yes, we are going to use the back. I click on V, letter V. I am now on the back couple layer. I come here, snake through, come to here. But if I connect it to here, it will not be connected. What do I do? I click on V. Again, I place a via, as I was talking about, and I come back to the top layer again. I didn't do this with the power pins because I don't want to think about the resistance of the vias. I can do this with the like CC pins, CC1, CC2 pins, because they're not drawing current. These are drawing current. I don't want to think about these vias, how much resistance does this have, how long does this trace have to be. I don't want to think about those. That's why I did it this way. Pull down gelecek. I click V again, add a via, connected, bam. We're done with that. I generally don't suggest doing this 90-degree of trace because it amplifies the signal, and I don't know the physics of it, but this 90-degree is always frowned upon in the PCB community. It adds noise, so I don't suggest doing this. So instead, I can like do this, like a snaking around motion. I try to.
So linear would be best?
Yes, linear will be best. So I change the place of via. I click on it, I change the place of it, bam. Now they are going, it's 45 degrees. Linear is the best, but if I need to turn. So how do? I do 45 degrees, another 45 degrees, and now I'm turned. As you can see, I did it here. 45, 45, now I'm turned. Another 45, now I'm turned this way. Yeah. And then we continue. Now I'm going to teach you. Okay. Now I'm going to teach you how to add power planes. Power planes are important if you don't want to like calculate resistances and like amperes and whatnot, and if you think that there might be surges, so it will really help with the resistances, and you will not burn the traces, because you are going to make multiple traces at the same time. You assign a plane to that power line. So let's do it here together. I come to this again, as I did power lanes. I click on here. Let's increase it a bit. I can change it with that, but I don't want to keep clicking on it. I want to decrease the bit so that I get more control of the zone. I want to control the zone as perfect as possible. Yeah. I click here. I choose 5 volts. Okay. Now I'm going to fill this zone all the way. All the ones that are going to connect to 5 volts. I connect them using this.
You're putting it to front layer, right?
Yes, I'm putting it to front layer because there is nothing in the back layer. Yes. Now I filled it. Now I filled it, and and I filled the zone. As you can see, now it's filled. I will turn off the back copy layer. This, as you can see, ground is separate from the 5 volt that I created here. Like you see multiple connections to here. If I want to improve this further, I can like play around, make this larger, make the plane larger, so that I don't have to think about it. And power planes are really good, so it saves you a lot of time. Yeah, imagine you have like 8 ICs. You're thinking, oh my god, which trace that I'm going to use and how much power conversion that I'm going to make. You generally connect your power source and then you pass it through a power regulator. Voltage regulator. You generally make the power planes there. You connect the voltage regulator and to your USB or whatever power source, maybe battery you're using, in the same plane, so you don't have to calculate the trace length like that. This is important. Yani burada yapmama gerek yoktu ama size öğretmek için yaptım yani bu power plane. Do you have any questions?
What happens if you put more than 5 volt layers? Can we put a bunch of them?
Yeah, you can put
It won't be
multiple.
full.
Yeah. And I feel it. I try to make this larger so that I don't think about resistance. See, there wasn't any connection here. I increased this size so that it can allow. Maybe I can increase this size as well to allow one polyfuse and shape. I have a fuse here, so I don't think it's gonna work. Yeah. Now, as you can see, I have multiple connections that I didn't make. KiCAD automatically calculated them for me. Yeah. And we are done with that. Let's open the copper layer back up and make sure that zones are not filled. Yes. I press B. Let's see which connections are we left with. And from now on, I connected the power lines. I am going to use 5 volts line to connect the rest of it. But for C3, for this, for blink in, blink out, I can use 2 millimeters. Yeah, 5 volts şey böyle ne kadar oluyor? Ne kadar çok az amper geçiyor bunun üzerinden. O yüzden 2 kullanabilirim yani. Now let's continue with this. I connect to as you can see, I was in back copper layer. I'm not connecting anything here. I'm not even there. I'm not even connected to the power plane that I made. I press V to go to front layer. I press it here. Bağlama easy man. Böyle yapıyor. They generally, KiCAD does not generally allow you to do this action. You generally start from the pad and come to the copper zone. Niye böyle oldu? Ne yapıyorsun? Connected, yes. Aynen. Şurada şey göstermiyor, mavi işareti göstermiyor. I check it before that. Bunu da buraya bağlıyorum. Buraya bağlıyorum. Wow. Now I connected my IC to the power. Congrats. Onun sonrasında. Now we can start with decoupling. Bu ne? Hayır, bu şey. Şeyin çalışmasını sağlıyor. Kaçın çalışmasını sağlıyor. Okay. We can, as we are done with the power, we can click on 2 millimeters traces. These are much smaller, as you can see. Look at this. These are much smaller. I can start from the bottom layer again. I snake around, come to here, add area, and connect it to here, and then I fix the position of it. I connect to the LED. I come to here. As you can see, it is not straight. I want it to be straight, so I click on it and make sure that this is straight. It's as straight as possible. Sometimes it's not easy. Ya bazıları mille yapıyor IC'lerine. Bazı komponentler milimetre cinsinden oluyor. Tam uymuyorlar birbirlerine. Ona yapacak bir şey yok. As you can see, this is one of them. We are going to connect this somehow. This is snakes around here. I don't want this. So I delete this one. I delete this one. I make sure that it comes like. I just clicked on it. I can move where this is going to happen. I can change. I can click on the wire and I can change the position of it. I just did that. I choose this, the second one. I hold it and drag and make sure that I don't have unnecessary wiggling around. That's just gonna add noise and resistance. I come back to here. I can just connect this through bottom layer and play this. And we are connected. I will connect this as well. So here. And then we're going to loosen this. Bu press M when I want to move things like that with my keyboard. I press M and I press the upper key to set the distance between them. And then I fill the zones again, I connect them, but I don't want to think about the beginning around again. Başka bağlamadığımız bir şey var mı? LED var. LED de bağlayalım. Yeni bir şey koyayım. I come to the front page. I need to connect to C3 that is missing. Let's keep it. Play, yes. Niye mesela bir şey yapıyoruz? We don't need unnecessary errors. We made all the connections now. This is a PCB almost done. We have like minutes away from making final PCB. As you can see, I can even cut this part. Like I don't need this part. Do you guys have any questions? I went fast. Did you guys able to follow me? It is late. Maybe you just gave up. I might have. And I think sure. I think everything is connected. Before I ship it, I click on DRC, run DRC. I will get a lot of errors, like this always. Clearance violation. Bunlar yapacak bir şey yok. We picked a clearance that is, we picked a footprint that is not compatible with this, but you can choose another. Yani bunlar şu delikler var ya, birbirlerine çok yakın. Ona izin vermiyor. KiCAD. Biz az önce constraint koyduk ya, diyor ki abi sen bunları neden böyle birbirine yakın koydun diyor. Ben de yani onları görmezden geliyorum böyle error'lar olduğu zaman. Terminal, these are not connected. As you can see, grounds are not connected. We need to fix that. Yes.
Sonra ground bölgesi mi ekleyeceksiniz?
Ground bölgesi mi?
Gerek
O da olur. Ama genelde şeyden sonra çıkıyor. Ground'a, ya şunlar bağlamış mesela. Bunların şu mesafeyi KiCAD'e ayırdık ya mesela. Bu kadar birbirinden uzak duruyor diye. Buralar hep boş kalacak. Onu da böyle göstereyim. We have the traces and the distance between here. Like this is the trace and the distance here is for the clear. Yani oraya hiçbir şey gelemez bak buralara. Bunun yakınına hiçbir şey gelemez. Ona izin vermiyor. That's why we come to 5 millimeters and then we connect to ground. Come here as well, connect it to the ground. I did it under the PCB, so it doesn't matter, you can do it over as well. I run the DRC again, look for more errors. Clearance violation. Diffuser arkadaşım olsa neydi? Yok o değil. Ne diyor? Thermal relief connection zone incomplete. Thermal relief zone dediği, onu da göstereyim. This, when you solder on the PCB, you have these 4 connections. These are for both resistance and for heat dissipation. So you want them to be complete as much as possible, but they're not that important. So it says that this is not complete. Look at this. There is only one connection here. What are you doing? He says that. But if I want to change that, I can just increase this and make sure there's a fill. I can increase this much. Make sure there's a fill, and probably it will still keep complaining. But as I increase the number of pads connecting to it, so I can just ignore that error as well. Turn the connections off now. Yes, this is incomplete as well. As you can see, each one's 4 sides. This has only 2. That's enough. This is kocaman pedal. Isısını dağıtsın. I go through them. Yes, we don't have any unconnected items. We connect all of them, and yeah, we are done. I can move these things around, make sure this is perfect, but I don't need to do that. Böyle, bunu mesela şey yapabiliriz şu an. Gönderip çıkartabiliriz. PCB hazır. To do that, how do we do that? I come to I come to fabrication output. I click on Gervers. Yes. I add edge cuts. Okay. Include layers. Sonrasında I choose output directory. I was looking for this. I come to here. I on my workshop folder. I add another folder. I call it production files. I am in it now. It will change the output directory to that. Yes. When I click on plot, it will send all the Gerber files to there. I also want to add the drill file as well. I close this. I come to files, fabrication outputs, drill files. I add them here to production files as well. It's automatically there. Generate drill file, done. I come to documents, I get production, kendi bilgisayarınızda nereye kaydettiyseniz oraya ekliyoruz. Kaydet projects, Bilkent projects, Bilkent workshop, yes, production files. I zip them, compress them, then just send these to just upload this to GLC PCB, and then you're done. Do you have any questions? You just completed your first PCB. Congratulations. Ben de görebilir miyim? Neler yaptınız? Do you have questions? I am almost done. Sonrasında minik bir şey daha var.
Bu dosyaları internetten bulabileceğimiz bir site gibi bir şey var mı yani? Yani mesela şeyler var ya, işte ne kadar pişireceksen, ne kadar şey kullanmayı vesaire hesapladığımız az önceki görüntüler vesaire, onları da paylaşacak mısın?
Şu doküman diyorsun.
Aynen.
Şunu mu diyor?
Evet, internette var mı?
Bu internette, bak mesela sizle beraber arayalım.
Tamam.
Direkt çıkıyor.
Tamam.
Yani, zaten bunu okuyun.
Tamam.
Yani PCB dizayn edecekseniz bunu bence detaylıca okuyun. Sonrasında, yani ben hepsini okumadım tabii, ben de ben de okudukça öğreniyorum yani, iyi oluyor. Ben bunu seviyorum yani.
Başka nerede doküman var mı?
Efendim?
Başka doküman önerisi var mı?
Yok da YouTube'dan önerebilirim. Şimdi benim YouTube kilitli mi? Kilitli değil. Okay. Fields'ler seviyorum ben. Fields'ler. Bu adamı izleyebilirsiniz. Let's paylaş değil. Slide gösterisi. Yes. General tips. Values'dan bahsettim ya. Şuradaki KiCAD'leri de göstereyim. Dedim, şuna tıklayın, buraya bunu yazın. These, write these to here. This is because this is not for the fabrication. This is for the assembly. If you send, for example, you go into GLC PCB way, and then you add your Gerber files, your drill files, and then you tell them to manufacture them. You can also choose the option of assembly. To do that, you need to have the values here, preferably. Also, you make sure that your tools, your footprints are correct. After that, you can come to here, file, fabrication output, and bill of materials. You also send them the bill of materials through production files. Same as BOM. That's a CVS file. It will tell you which components that you're going to get. Assembly istiyorsanız bunu da yapacaksınız. Yani mesela şu kadar diyor. Buna aparat bu olsun diyor. Print bu. Bunun assembly'sini yapın diyor. Bunun value'su bu. Designation. Value'ları buraya yazdık ya. Burada çıkıyor. O yüzden biraz da.
Kostu ne kadar arttırır?
Neyi?
Mesela Robusta mesela
Bomba beraber göndermek. Assembly yaptım abi.
Assembly'yi de istemek.
If you are going to make SMD PCBs, you want them, yani o arada 5.000 10.000 lira hiç olmaz. Çin'de yaptırması çok ucuz. Çin'de yaptıracaksan yaptır gitsin. SMD yapması, SMD soldurlaması da ölüm. Ölüm. Onlar yapsın. Sen yani STM32 vereyim buradaki herkese STM32 bir tane PCB'ye soldurlayın diyeyim. Belki sabah bir kişi yapar. Yani biraz zor. Belki yani çok yeteneklisiniz de ben yapamıyorum mesela. Yani şeyde de stajda da yaptığım şey.
Gösterdiğim videoda hangi STM kullanıyorlar? Bu dönemin başında biz de STM'le PCB yapmamız gerekiyor da.
Ha öyle mi? Hiçbir fikrim yok. Ama şey yapabiliyorsun. Footprintlerinden, ya package'leri benzer oluyor.
Yok, şimdiden footprintlerini atamaya library dizmeye başladık.
Aha.
Bir sonraki dönem biz de şey yapacağız.
Sistemi çalışacağız.
Evet.
O hangisini yaptığını bilmiyorum. Antenli de ama bunu da ya bayağı 2 yıl önce izledim. 2-3 yıl önce izlemiştim o yüzden yani hatırlamıyorum. Yani bir süre oldu. Sonrasında.
Sonraki gizli bootload yapamazsak onu yapacağız.
Application cheap voice and if you had soldering to by ICs. Ah, IC socket. This is really important. This is pro tips. This is the pro tips section that I thought about. IC sockets. So if you have TH components and you are going to solder them, you might damage them if you heat them too much with your soldering iron. So I'm assuming if you are going to make PCBs, you are going to solder them using a soldering iron and THD components. I hope you're not going to like try not to solder assembly components. Maybe you can. Yani onun için özel şeyler oluyor. Bir kişi tutuyor şirket. Adam 20 yıl boyunca çalıştırıyor. O teknisyenleri kaybedince mesela nasıl solderlayacağız'a geliyor. Yani o biraz zor iş. So I'm assuming you're going to make PCBs that are TH and I see şey kullandık mesela NE555 LED. We use that. If you're going to solder it, you might damage it when you heat it too much. Instead, you use IC sockets, you solder them, and then you plug it in. I suggest using IC sockets for the ICs. When I got both Chinese versions and Turkish versions, for the Turkish versions, don't try to heat them for long time. Using your soldering iron, don't heat them too long. You're going to böyle kalkmak, Allah ilk kalkıyorlar böyle. Yani onu tavsiye etmiyorum. Try not to heat them for more than 15 seconds. But Chinese versions like last much better and much longer. So